can be used at CERN, and I will give you a detail about the wire scanners, how they work, what's their design, and specifically I will be talking about the selection of the wire. Right, in this scanner there is a wire that interacts with the beam that is passing inside the collider. When it interacts with the beam, it gives us the idea about the beam profile, and the selection of that wire is going, like I'm going to talk about that selection in this PowerPoint, like in this presentation. So let me give you an introduction about Large Hadron Collider. It's the world's largest and the most powerful particle accelerator. There are multiple accelerators at CERN, but the LHC, the Large Hadron Collider, is the most powerful one. It started in like 2008, and the best part is it's the largest laboratory on Earth, like 27-kilometer long ring in which this system is operating. And the conditions we need to worry about are that there are high cryogenic conditions and the high vacuum conditions are like in which the whole design and the whole apparatus is working. So in the design of our equipment, we need to consider these conditions there. So let me talk about the particle detection, a little bit about the particle detection. Actually, this thing was interesting, so I added it here. So how do we detect particles? There are multiple devices that are used for the tracking. In those devices, there are tracking devices, and then there are calorimeters. Tracking devices actually track down the path of the particle, like the path taken by the particle. It is tracked down by those tracking devices, and then there are calorimeters. What happens in calorimeters is that a particle passes through a sheet of insulators, like an electromagnetic particle. It will pass through some insulators, and there will be a decrease in the energy of the particle while passing through it. And that energy, that decrease in the energy, is calculated, and it is used to detect the particle, specific type of particle. Another interesting thing was the methods, that how these particles are detected. So in those methods, there are Cherenkov radiations and the transition radiations. I added this thing because it is a very interesting thing. The Cherenkov radiations are actually the radiations that are produced when a particle travels faster than the speed of light in a particular medium. Like we know that, for example, in water, speed of light decreases to like 75% of the speed of light. So whenever in that water, an electromagnetic particle will move faster than that light, it will give us some specific radiation. It is same as the supersonic jets we get from the when something travels faster than the speed of sound. This is the same thing is happening.
Like the group velocities are the high velocity when you carry those particles. Okay, so the velocity of the particle which is traveling in that medium, should it be greater than the group velocity of light in that medium, or like the phase velocity?
Well, I have no
What
idea.
might be the group velocity?
I have no idea about that, and I will look into it. But the whole particle, I think phase velocity cannot be
Okay, you can.
perfect. So another thing that there are different type of calorimeters, hadronic calorimeters and electromagnetic calorimeters. Hadronic calorimeters detect heavier particles, and electromagnetic calorimeters detect lighter particles. So that was just a slide about the detection. Now let me start talking about the wire scanner. Actually, this is the device. This is the wire scanner. So I will talk in detail about everything. So let's start talking about this equipment. That there are a few important things in this scanner. Like in this device, there's a high vacuum compatible motor that is installed there, and then there is wire attached to that motor, and that wire is rotated, and the rotation of that speed ranges from 5 meters per second to 20 meters per second. And then when it rotates, it comes like it interacts with the beam that is traveling inside the collider. And when it interacts, there is a production of secondary beams. And that production, those secondary beams are used to get the profile of the beam, and it gives us the intensity. It is used to calculate the intensity of the traveling beam. We can calculate the intensity of the beam using this device. So this is the design of the scanner. You can see that these are the machining forks. These antenna type things you can see. These are the machining forks, and to these forks the wire is attached here. Here we can see the wire is attached to the machining forks, and this is the shaft. On the shaft, machining fork, fog, and this is the